Okay, so let's look at another one. This time we'll actually make use of both sides x and y directions, okay? And this is a wider class of problems called projectile motion, okay? The motion that it follows like a projectile, you project something at an angle and it follows like a general arc, a general path, right? Okay, so this is a very typical problem, like this launch at a certain angle and a certain speed, and ask how high, what is the maximum height it reaches. Okay, so let's look carefully at what is given first. It's given the angle upwards from the horizontal, right? So we actually know how to draw. Notice the three pieces of information to give directions. And then the speed, which is the magnitude of that velocity, is 100. And it looks like things are given in sort of 3 sig fig, so we'll keep a mental note and ask the maximum height. All right, so let's follow the same steps and draw that out. Right, so we have a horizontal and you're launching a disk at 60 degrees from the horizontal, and you're launching it with 100 meters per second. Okay, and since it's SI units and the fact that I wrote U mean I know this is already in SI base units, I'll just write that and I will know what it means. I know the initial speed is that. Notice I did not put a vector this time because I'm talking about the magnitude of this. So let me put it here just because I know what I want to draw in a moment. And then it's going to follow this sort of general path like this, right? And now be careful. The next potential complicated thing is, well, you're going to write down SUVAT for both x and y, like that, right? Now, this is displacement, right? So it's very tempting. You go like, oh, let me pick that displacement. But then if you're picking this point and this point, you can't really analyze the maximum height. So displacement is always between 2 points. So you don't want to, for this problem, you don't want to pick these 2 points. And if I want to ask how far it reached, this is the displacement, or this is the initial, and this is the final point you want to analyze. However, this time we're interested in just the height. So you don't really care about what happens afterwards. So it's better to pick this as your final position. So now I can actually talk about the displacement between the initial and final would be this, right? Otherwise, I would be analyzing the SY, the vertical displacement between these 2 points. And that displacement, of course, I don't even need to do any math. I know that that's 0. There's no vertical displacement from here. There's a horizontal displacement, but there's no vertical displacement between the initial and final over here. So that's why we're not going to pick the final point over there. We're going to pick the final point over here. All right. So this is going to be the SX. This is going to be SY. While we're at it, make sure you define positive X, positive Y. Right. So that's where my origin is. And I'm going to measure displacement from here, and vertical displacement from here. Okay. So what are my givens and what are my aims? So my aim is to find the maximum height. So basically, I want this. Okay. So that's going to be my aim. Now, SX, I don't know. Do I know UX? What's UX? UX is the X component of the velocity, right? So what we need to do is use our knowledge and how to resolve this vector, right? So you have the X component and the Y component over here, right? UX, UY. All right, we're given the 60 degrees. So you have a right angle triangle over here, right? So you know the magnitude is 100. And now you want to know UX. So UX, since this is, we can use the quick trick, right? If not, you can just draw out a separate triangle as yourself, right? This is 60, this is 100. What is this? What is this? Right? You can do the sine cosines, but I'll use the quick trick. If I want to find this and it's sandwiching the 60 degrees that I'm given, it's sandwiching the angle that I'm given, I can just use, it's basically U cosine theta, right? In my case, 100 cosine 60 degrees, like that. Okay, and yeah, so I also know that 60 degrees is 1/2, so I can technically just put this on there, but just for completeness, maybe I'll put 100 cosine 60 like this, so we know where things come from. Okay, and uy, if one of them is cosine, the other one is going to be sine, so it's going to be 100 sine 60 degrees like this. Okay, quick word of warning is, when you're writing angles, when you write degree, something, if it's in degrees, always write degrees. If you don't write it, it's in radians automatically, right? So radians is another unit of angles, so make sure you write degrees. All right, so Vx, do we know what's the x velocity over here? So over here, where is it going? So if it's going like this. So the maximum height is actually the point where the velocity is completely in the x direction, right? Because if you have a y component, then that means in the next moment, it's going to be higher, right? So that's not the maximum point. If you have a negative Vx for a Vy component, that means the next moment it's going to be lower. That means previously it's higher if you have a Vy component. So the maximum height point is the point where there's no y velocity. It's momentarily stationary, right? So we actually implicitly know this by just the question asking for the highest point. Okay, that does not mean that Vx is 0. Notice the Vx is unaffected by it. In fact, do we know what is the acceleration in the x direction? We actually do, again, implicitly. Throughout the whole projectile motion, there is no forces in the x direction, which means there's no acceleration in the x direction. And y there is minus g. So do we know Vx? Not obvious, but again, if you think about it, if there's no acceleration in the x direction, then the velocity will not change. So technically we do. But even if you do, if you don't, you can actually put a question mark, and then you can find it using one of the equations. For example, I think we did a similar example before. Let's say you, for example, u equals v plus at, right? Like that. If your a is 0, so you don't have this, so you immediately will solve that ax, right? So if you can immediately solve that as well. So it's up to you. If that is 0, it's up to you if you want to put that as a question mark, or if you want to just go, oh, it's common sense. If it doesn't accelerate, then that's also known. All right. So I'll put that as a 0. Sorry, I'll put that as a question mark for now. Because yeah, it's either way, but I'll just make that so to let you know that you can do it even if you don't write it down. And do I know the time it takes from my initial point to my final point? No, I don't know. All right. So that's all my information. I know what my aim is. Okay. My aim is in this column. So I want to stare at this column and see, do I have 3 pieces of information? And look at this, 1, 2, 3. It looks like I do have 3 pieces. So now I can go ahead and pick an equation and solve. So I want an equation with no time, right? No t, because I definitely want an s, because that's my aim. So be careful. Sometimes you'll go like, oh, I don't know this, so let me pick an equation with no s. If you do that, you will never find s. So you want s to be in your equation, but you don't know the time, so that's the one you want to leave out. If I remember it correctly, I have v squared equals u squared plus 2as, right? Now, I'm interested in this column, so let's put a y everywhere. Do I need to put a y on an s? Yes, right. Everything has a y here. Only t is the one that doesn't have a y. And then it's plugging all the numbers, right? So I have 0 on this side, 0 squared is 0. This side I have 100 times sine 60 degrees squared plus 2 ay. Be careful of the negative, 9.81. And s is unknown. This is what I want to solve. Okay. So go ahead, try to plug this in the calculator and see if you get the same answer as I do. Since it's a lecture, let me show you something that is in your homework. At this point, you plug in the calculator, but I want to teach you sort of general physicist skill as well, so outside of the classroom, because outside of the classroom, you're not going to do the homework. Things are not going to be to solve real life problem. It's not going to be tailored like homework problems, right? So if you have a real life problem, you go like, I know roughly if I kick a ball, it will launch at this speed. Let's say you know roughly, or you have a cannon that can do that, and you know what the angle is, and you want to find the maximum height. All right, what can you do? You can do simple estimates, right? So I'll show you how to estimate. For example, you can change that into 10. How bad am I if I make that? Is my calculation if I made that approximation? Well, 9.8 and 10, that means it's roughly 20% off. Okay, so what does that mean? If my answer is if I want to find a time, for example, and I find that it's 4 seconds, let's say. So 20% off would roughly just be 20% off of this. So what's 20% off of 4? 20% off of 1 is 0.2, right? Plus or minus 0.2, that's 20% of 1. 20% of 4, that means plus or minus 0.8. That means my estimate would be 4 plus or minus 0.8, roughly. Yeah, that's not entirely how it works, but just to get a rough sense, 20% off means it's either, I will estimate, if I estimate something as 4 seconds, it will either be 4.8 seconds or 3.2, okay? Somewhere between that range, okay? You might wonder, well, is that good or bad? Depends on what you want to do. If you want to have a rough estimate of things, that might often be sufficient, right? And the point is, if you want to be more accurate, you can pull out your pocket calculator and actually make it more accurate. But sometimes you don't always want to pull out a calculator, so you sometimes want to be able to do things in your head. This is a good way to do it. And I'll show you, you don't even need a calculator, right? So for example, sine 30 degrees is 1/2. Sine 60 degrees is square root of 3/2. Okay, so these are common angles that it's sometimes useful. The more you see it, the more you remember it. So the square root of 3/2 squared plus, well, 2 times 10. So I should do minus 20 sy. And on the left, I have 0. Okay, so I can put this on the other side. So 20 sy equals to 100 divided by 2, that's 50. 50 square root of 3 squared, like this. Okay, and so I can square the 50. Let me get some space over here. Yeah, so 50 squared, what is 50 squared? Well, I can do 5 squared, so that's 25. And it's 5 times 10, right? So what you can do is square the 5 and square the 10 separately. Right? So squaring the 10 will give you 100. So that is, what is it? Essentially in my head, what I'm doing is change it into this. Okay. So now you can square everything, right? So it's 25 times 100 times 3. Once you put the square in everything. So if it's times, remember, don't do that if it's a plus. It only works if it's a times, okay? So it's this times 3 equals to, on the left, that's 20 sy, right? And now sy is 2500 times 3 divided by 20. One of the zeros can go. 25 times 3 is 75. So I have this divided by 2, which should be 375, I believe. All right. Yeah, so that should be my answer. I think I should put things in 3 significant figures, although I've done an estimate, so this is not too accurate anyway. So we'll leave that way. Do I have plus or minus? So check 3 things. Units, right? So what unit is SY? Meters. Okay. And significant figures, won't worry too much about that. Here, plus or minus, so I got plus. Does that make sense? So it was a projectile, and I'm asking for the maximum height it reaches, right? So that makes sense because I put my origin at the bottom. So now the vertical displacement is that much. So that looks like a good answer to me. All right, so that's how you solve it. And now you see sometimes you need to resolve vectors to do it. Like I said, the second part of it just is more for lecture purpose to hopefully you learn some general skills and advice along the way. For homework purposes, the moment you pick the right equation and plug in here, you're almost done. All right. Just to emphasize that is we always say that in the homework, 80% of the grades go to presentation, the quality of the solution, and 20% is just the answer. As soon as you're done with this step, you should almost get 80% of your grades. Everything else, I will show you some. I was just showing you some tricks. Hopefully, it was useful. Just even if you don't have to master it, just sort of learn this idea, the concept or the approach or the mindset. But yeah, everything else is what I consider algebra and calculator work. Okay, so yeah, all right. We'll see a few more just to get you more familiar with this, and you can see it really starts to become a pattern. And once you understand how to solve these as a pattern, it will become easier and easier.